So this is the first time I built a three-wheel drive electric tilting Tadpole Trike. This footage is from either February or March of 2023, after I completed this proof of concept. This project came about because of two things. The first being access to discarded bicycles I definitely didn't salvage from the scrap metal pile at my local dump. These bicycles were cheap 26-inch 18-speed hardtails, the kind that people buy from big box stores for their children to ride twice before forgetting about until some years later when they're tired of them taking up space and it's time to throw them away. The second thing that made this possible was an armful of e-bike front hub motors that I found online at a price I couldn't pass up. I found the motors on a website that I usually use to buy batteries for cell recovery. The listing didn't say where the motors came from, but since there were so many of them, my best guess is that they came from a decommissioned e-bike fleet. The website sold fully intact wheels, of which I bought a few to convert bikes for my family, but the real deal to be had was on the hub motors that were sold unlaced, that is to say without the spokes and rim, of which I bought several at $27 a piece. But before this could become a three-wheeler, I needed a frame that felt stable on two. So I grabbed one of the discarded frames and started cutting. I chopped off the top tube, chain stays, and seat stays, shortened the seat tube, but kept intact the head tube, and bottom bracket. My purpose with what remained was to maintain the head tube angle and reuse the bottom bracket as the pivot point for a swing arm. The main materials and equipment that I needed to move forward were 1-inch mild steel tubing, a tube bender, and a welder, all of which I had to order online because there were none to be found nearby, or at least not at the price I could justify. I used the steel tubing to expand the bicycle's frame and create a structural compartment where I was then able to house the batteries and controllers. Then, off the back of the body, I welded on support for a seat that would also be used to secure the rear shocks. This being my first foray into fabrication, it didn't go great, but it was good enough to get along. Since the chain stays and seat stays were gone, I needed to make a set of swing arms. I went to work with my hammer, flattening out large sections of 2 pieces of tubing. On the front end, I cut square holes to match the bottom bracket, and for the back half, I cut long slots so I could adjust the wheelbase. Then I rode for a while with the shocks zip-tied to the frame and swing arms until I found a position I liked, and welded on permanent mounts. After the frame was welded, I enclosed the compartment with a coarse chopped strand fiberglass and epoxy, making a solid structural shell. Lastly, I moved on to the front, the entire point of the project, the parallelogram. For the wheel wells, I used more of the 1-inch round tubing. I hammered the ends flat and reinforced them to make the dropouts, but never found motivation to add any brake mounts. I'm riding slowly, even though this can get up to higher speeds, because I only have a single 160mm disc brake on the rear. This build turned out quite heavy, and with all that extra inertia, it would be foolish of me to take it to its max speed. That being said, it also doesn't handle well on asphalt. After drilling some misaligned holes in the wheel wells, I was able to use some scrap flat steel bars to connect them to the central pivot point. The central pivot point was made of square steel tube and bolted into the dropouts of the bike's original coil spring suspension fork. The motors were useless when they arrived, and I, refusing to spend too much more money, decided that I would reuse the spokes and rims from the original discarded bikes. After plugging the hub motor's dimensions into a spoke calculator, I cut the spokes to the specified lengths and rolled new threads onto the ends. Then I laced the hubs onto the salvaged rims and had new wheels from old parts. The electronics controlling the setup were as sketchy as everything else I've described so far. The motors themselves were rated for 36 volts at 250 watts, so naturally I used 48-volt batteries and 350-watt controllers. The motor controllers were cheap and easy to find online, which is great because each motor needed its own controller and display. The throttles I had to play around with a bit to get to work properly. So on the right side of the handlebars I have a full twist throttle that controls the rear wheel, and on the left side of the handlebar I have a thumb throttle that's connected to both of the front motors. Like the throttles, I have two batteries, one for the rear motor and one powering both of the front motors. The two batteries aren't for redundancy or capacity, it's just that I couldn't get one battery to power all three motors at the same time. At this point I had wanted for a while to try my hand at building a tilting trike. Having already put time and effort into learning how to build my own battery packs and lace and true and round my own wheels, metal fabrication wasn't a large leap to take. The most important part of the entire build was making the trike tilt, because in my mind, without the ability to tilt, this trike would have no advantages over bikes or quads. But a tilting trike combines most of the stability of four wheels and the freedom of motion that you get with two wheels. While rear-wheel drive would have been the sensible way to go with this, I am a nonsense person who bought a lot of low-powered motors, and so had to make this all-wheel drive. And I'm glad that I did, because it gave me extra traction to tackle adverse winter conditions. Its performance on snow and ice is also surprisingly superior to how it handles on asphalt. So, for the next couple of years, I committed to riding this around and making some adjustments to the design. I cut off the lowest parts of the parallelogram and moved up the pivot points. Played with the camber and wheel sizes, going through many iterations to see how these changes would affect the steering angle and handling. I also added springs going from the four corners to the middle of the central pivot point that helped the parallelogram return to a neutral position. Through this, there was only one time when I had any problems with the trike. Thankfully, I was only a couple blocks from home when two nuts fell off of the bolts that I was using for the pivots, and the parallelogram collapsed. After walking the trike back, I decided to buy nylon lock nuts for better bolt retention. The frame ended up fairly wide because of the radius of the tube bending die, so I rebuilt the frame one more time. I found another frame that was the same geometry as the original, bought tubing that was slightly more slender and could bend to make a more narrow body. I've also recently rebuilt the parallelogram with square tubing rather than round, which led to better hole alignment and superior stability. The square tubing also made it much easier to mount disc brakes to both of the wheel wells. Lastly, I was able to obtain a rear hub motor for free and make a version of this trike that is also pedalable. So if you'd like to see more on these, keep your eyes out. And thanks for riding with me.